Hey, nothing says it's 6 o'clock like an alarm like that. All right, so my name is Dr. Blue, and I am the Associate Director of the STEM Center for Excellence, and I'm hosting these review sessions in partnership with the Mathematics and Statistics Department. I have with me two CECs. I've got Stephen Morrison and Shannon Redmond, or not Shannon, sorry, Madison Redmond.
Yes.
I've looked at too many names today. It's been a long day. And they are going to go through this review packet that you have in front of you. If you haven't gotten it yet, Dr. Jenkins will be back with a review packet. And so what we're going to do is I'm recording this. Whenever you are signing into that sheet, if you could provide your EKU, I think I'm at UK again, wow, your EKU email address and print it clearly, I will send you this marked up version of the notes tonight, and I will send you a link to the video recording in case you had questions about how something was worked out or need to see it work again. So for this final exam review, I have arranged this by learning outcomes that I found in the materials in your Blackboard course. There's a lot of supplementary materials. I know you guys are pressed for time and maybe didn't have time to look at those, but the learning outcomes are really powerful because they allow you to say, all right, with the information I just learned, what do I need to be able to do with it? They really answer that question, is this going to be on the exam? And if so, how far is it going to be? And so they're organized by difficulty with Bloom's taxonomy that I've included here. And whenever you're working through these learning outcomes, it's really important to go through these steps and ask yourself, all right, if I have a learning outcome, do I recognize all terms in the question? So if we go down and look at our first learning outcome from the Chapter 3 Algebra Toolbox, it says simplify expressions containing exponents. Well, that one, yeah, we know the terms, but what if we come down to something, okay, well, what's a radical? All right. Maybe you don't remember what a radical is. Make sure you define all the terms before you try and attempt any work. Just go ahead and have a seat. Thanks for joining us.
Where's the paper?
Pardon?
Where's the paper?
We'll pass more out. All right, so then next with those learning outcomes, you want to make sure, do I understand what the question is asking me to do? Can I find examples of questions that match those learning outcomes? So that's what I've done. I've gone through each section of your textbook and I've found example problems I think most closely match that learning outcome so you can get some practice and maybe start to see some common themes with how they work. Once you get through those first three, then can you answer the question? And most importantly, do you know how to go back and check your work? So if you're solving for the root of a polynomial, do you know how to plug those roots back in to make sure that, yeah, they really are solutions and they don't give you some imaginary number that's not a real solution. All right, so the way this is organized, right? Since the midterm, you all have covered 5 sections in Chapter 3, 1 section from Chapter 4, and then 3 sections from Chapter 6. We do have these Algebra Toolbox sections. And while I will not go over these tonight, that's kind of like the foundations that we're building our house on. So if you're having any difficulties with any of these Algebra Toolbox learning outcomes, you want to make sure that you go back, read the textbook. Your math textbook is actually fairly readable. And if you need help translating it to plain English, that's what your course embedded consultants are, like Stephen and Madison here. That's what your instructor is for. Talk to your instructors in 111, 112. Go to the Math Tutoring Center, go to the Student Success Center. Make sure you're getting those questions answered, okay? Your success in this course is what we're here for. All right, so with that being said, what we'll do tonight is we will go through, okay, we're going to skip Chapter 3, the Algebra Toolbox, thank you. And we will. There we go. We will start with section 3.1, looking at these learning outcomes. And so in some cases, I've added some notes to these.
Who do I give this to?
Just hold on to it. Whenever somebody new comes in, we'll pass it to them. And so if I have found useful notes from your textbook, I have added those here. And that way we've got, our note package marked up a little bit, and we can keep adding to that as we're working through problems. So if there are any questions you want to see worked, that's what I've got these guys here for, and they will work them out for you. All right, so for those of us joining by Zoom, I'm going to drop this packet in the chat. And then everybody will have a chance to take a look at it. So if you guys just want to start flipping through that and see what looks tough. We can focus on the challenging problems tonight while we have help. That's the goal.
I don't have a packet.
I know, she's coming back with more. Okay.
This question is pages 9.
Yeah, don't worry about that so much. Why don't you just go ahead and, why don't you just go ahead and read through each of the learning outcomes and ask, just call out if you have questions over that.
All right, so the learning outcome of this first section is describe characteristics of the graph of a quadratic function. So this is talking about if it's quadratic or not, or if it's concave up and down, what the vertex of a graph is, and whether that's a maximum or a minimum point on the graph. So if there are any questions about that one, like she was talking about, she put this excerpt from your book up here, and that's a great resource for answering all of those questions. But if you still have questions about that, now would be the time to ask those. This review session is for you all and whatever you all would like to cover. There are questions you all are struggling with specifically, or if you say, hey, I may not know how to do this, or I might know, but I'm not confident. No questions? Is there any in the chat?
Nope, none in the chat.
All right.
Okay, and if we flip past some questions and you still like to see them work, feel free to just holler it out and we can go back to it. That's not a problem. Yeah, don't spend too long on one section.
All right, so this next one says graph quadratic functions in a given viewing window. So this is all about using your TI-84 calculators. Getting comfortable with those is a big help, especially on your tests and in general. Those calculators are very powerful, and any question that is asked on your exam, as long as it's on the calculator portion of the exam, it will help you solve. So this is talking about, do we know how to put in windows and adjust our windows need be? Good. This next one is write the equation of a quadratic function given a graph or points on the graph. So, like the beginning, there is a little section here that we can use to help us if we need to study this in the future and we don't have any questions now, but we find one later. It's using your book, because all these are in your book, right? Is a great resource. Learning to read your book is helpful when you get stuck. It's helpful to read it always, but I know a lot of us don't have time for that. So it's always great when you get stuck to go straight to your book, because that's where we get the questions from.
Can you show us how to work that one out?
Sure. So let's see. This formula right here helps us find all of these. So we know that the graph of our function is equal to y equals a times x minus h squared plus k, where the point hk is our vertex. So imagine these h's and k's were x and y, right? Because that's how we're going to look at this. I know we already have an x in here, but This is just for referencing terms. So this vertex down here is 2, -4. So that's our X and Y, or so 2 would be our H, so H is equal to 2, and K is equal to -4, right? So we can go ahead and plug in Y equals, we're gonna save room for A because we don't know that yet. X minus, well, our H over here was 2. So X minus 2 squared plus, well, we had -4, so that ended up being a minus, right? -4. And that's where we are. So we got this part. Now let's read the rest of what this says. If the parabola opens upward, if A is greater than 0, and the vertex is a minimum. The parabola opens downward if A is less than 0, and the vertex is a maximum. So we know that this is a minimum right here, because it's at the bottom, right? So our A must be greater than 0, right? Because it's opening up and we have a minimum. So let's keep reading. The axis of symmetry of the parabola has an equation x equals h. So our axis of symmetry is just 2. So if we were to ask what's the axis of symmetry, we can just look at our vertex and say, hey, the x coordinate of our vertex is going to be our axis of symmetry. Now let's look. The A is the same as the leading coefficient, and y equals ax squared plus bx plus c. So the larger the value, the absolute value of A, the narrower the parabola will be. So how are we going to find it? It's a great question, because I don't remember, I'll be honest. Do you remember how to find A here? Because I haven't done it in a
So
while.
if you go over 1 unit on the X value,
You always just use the calculator for it.
All right, so you guys that are so stuck with your calculators, love y'all, but this is how we kick it old school. All right, so we've got this vertex. We know we've got 2 points here. And later on in this section, you learn how to use 2 points to find an equation for a line. And so we know we've got this vertex where we're at 2, -4, but we also have this point here, 4, 0, which is our XY pattern. And so we can just drop X and Y in here. We still don't know A. And when we drop X and Y in there, we can solve for the value of that A. Okay, do you guys need to see that done, or is that good enough to get you going?
What page is that?
This is on page 10, bottom of page 10.
And this is page 6.
Okay, so does somebody want to see that done, or is that,
Well, this, the last time you sent that. this-
oh, you know what, that's paginated differently. It is on page 6.
Did you say something about this?
Okay, I've got a message that someone would like to see this work out. So to work this out, I'm going to take this XY point from right here. And for Y, I'm going to plug in 0. I'm solving for A. X is equal to 4 minus 2 squared minus 4. And so then I just work through this. 0 is equal to A times 4 minus 2 gives me 2. Then let's square 2 to give me 4 minus 4. So I have, at this point, 0 equals 4A minus 4. We're going to add 4 to both sides, so we get 4 is equal to 4A. Isolating that A by dividing both sides by 4, we get A is equal to 1. So our final equation for this is Y is equal to X minus 2 quantity squared minus 4. And if you guys have signed in and I can read your email address, I will send you these notes as soon as this session is done. All right? Questions over that? All right.
They want to go on all your chase.
That's why I'm here.
Yep.
Does everybody have a chance to write that down?
Quick question. You said, I'm pretty sure last time you said that this meeting would be recorded or something.
It is being recorded, yes.
How will we be able to access it?
I will email you after this is done, if you've signed into my sheet, and I can read your email address. So I will send you both the recording and this marked up set of notes.
All right.
All right.
Yeah, so you'll get a document of this. Any other questions in this section?
Okay, did anybody need to see 18 or 19 worked?
Awesome. So it says, find the coordinates of the vertex and graph the quadratic functions. So, as it says in our instructions, it says, give the coordinates of a vertex and graph each function on a window that includes the vertex. Any questions on those? Yeah. Number 23. So we know that y is going to be equal to 23. Y is equal to x plus 8 squared plus 8. So find the vertex of this graph. Well, do you remember from our little section up here how we found the vertex, or what the vertex was? The graph of the function is a parabola with the vertex at the point hk. Well, h and k are just right here, right? So let's go back to our problem. So we know that x minus h, so that's a plus there, which means it's going to be a -8. So our vertex is going to be -8. Now let's look at our k. It says plus up here, plus k. We still have our plus over here, so that's still going to be our +8, so our signs did not change. So our vertex is going to be -8, comma 8. Then it also says graph each function on a window that includes the vertex. So we know that it's going to have to at least include the vertex. On your calculator, I'm not sure if it wants us to draw, you know, if it wants us to draw it.
Don't worry about drawing it.
Yeah. So on our calculators, we've already solved for our y equals portion here. And that's what we need to put into our calculator. So we just type it. x plus 8 squared plus 8. Now, we want to find a window that includes the vertex. There's a couple ways to do this. My favorite part of the TI-84 is if you press zoom and then go down and scroll down to where it says zoom fit. The calculator is great at guessing that window. It is great at guessing that window. But other than that, if we know that our vertex is at -8, comma 8, so we want to at least include that point, we're going to need a range around our x. So we need a range around x, which is -8, and a range around 8 for our y. So this is going to be our x range and our y range. My recommendations, since our slope is just that 1, I would just put it in our standard window of 10. So we could just add 10 to the y range, which would be 18, and subtract 10, which would be -2. And we could also create a range of this, of our 10, which would be -8 minus 10, which is -18, plus 10, which is 2. So our x window would be these right here, 18 and the 2. Our y window would be this, and that would center our graph at the -8. That make sense?
All right, any other questions on 21 through 30? Okay, awesome. How about the next section? We've got 31 through 30 or through 40. Did any of those look too tough?
Those are going to be very similar to the one we just did.
All right, moving ahead. How about, let's see, using the graph of a quadratic function to estimate the x-intercepts. Any difficulties on 41 through 46? If you see one that you'd like worked and we move past it, just let us know. We'll go back to it. All right, how about the word problems based on all of this information we just looked at?
You do it the same way you just did the other thing.
Yeah. So scroll down just a little bit. So are there any of these word problems you guys would like to see worked?
Like number 47, I'm talking about, if you do the other, I do the same way. Just do other problems.
Yeah, can you talk us through that?
Yeah, so first it says graph the function for x's between 0 and 3200. So that gives us our window. So all we have to do is plug that in our calculator, and it's where x is between 0 and 3200. So as long as we plug 0 and 3200 into that graph, it'll give us our function of what's happening. We may have to adjust the y a little bit because it may go up really steep or not. And that's just kind of something you gotta mess around with. But that's where we can look at B. Describe what happens to the profit for this product when the number of units is between 1 and 1600. So X is the number of units processed and sold. So we want to know what happens when X is between 1 and 1600. So as a rough graph, this graph is going to look for profits, something like this, just a nice little parabola. And so between 1 and 1600 here, it's probably going to look like it's increasing. And so that would be our answer. We would say from 1 to 1600, the profit's increasing. But now, what happens to the profit after 1600 units are produced? So if we were to look from 1600 and on, so down to 3200, I'm willing to bet 1600 is probably our vertex where it goes down. And we could find that by applying a vertex formula by using our calculator to find the vertex or the maximum of the graph, or a couple different ways. But so this first B part is just this section here. The C part is this section down here. So B and the C. And so we would say increasing, decreasing there. Yeah.
Okay, so when you graph the function, do you just top the function into y equals and then use Dr. 0 to 3200 as your windows?
Yep.
Okay, I keep getting a straight line, so what am I doing wrong?
So does it look, did you make it your X for 0 to 3200?
Make it my, yes, both of them are my x.
So your graph is going to look something like this, and then probably,
What do we put in for our y?
your Y is where I said you may have to mess around with it. But a great way to know is we can look for that vertex and plug that back in. So if we found the vertex, so that would be our negative B over 2A. So that would be negative 32 over 2 times 0.01. Negative 2 times 0.01. Do that in your calculator real quick. Is that 1600? Anybody?
You're 0.16.
So let me double check.
Oh, wait, I didn't finish.
I got 1600. So that's our vertex. So we know as tall as the graph gets, our vertex is going to be at 1600. So I would just throw in 2000, just some halfway obscure, but just a little taller than 1600 so we can see the whole graph. So it'd be from 0 to 1600, and it should give us something like that. Because our zeros are probably 0 and 3200. They usually like to make these things look nice when I give you these. But But from there, we could look at our ranges and say, hey, what's happening here? So you may have seen the straight line because your range would have looked like that. And so you'd be like, oh, hey, that's increasing. And then if you looked at that second range, you'd have a graph that looked like that. So this would be our B graph and C graph. Does that make sense?
All right, any other questions over these word problems? Mostly at this point, it becomes translating it from the words into what are the equations and the pieces and the meanings for the variables that you need.
So there's some more word problems as we go down. This one says, answer interactive figure questions involving quadratic function graphs. Any question on those?
Yeah, I don't understand anything that says
61.
61 or 72?
61.
Says if 200 feet of fence are used to enclose a rectangular pin, the resulting area of the pin is A equals X times 100 minus X, where X is the width of the pin. Is A a quadratic function of X? I would always recommend when you see stuff like this, get it in the form that you understand best. So what happens if we distribute this X out? We would end up getting that A is equal to 100X minus X squared. So is it a quadratic function? What makes a function quadratic? Anybody?
Is it X squared?
It is X squared. So if we see an X squared, we know that's going to be a quadratic function. Because our graph, no matter what, is going to be some variation of X squared, which is our parabola that's quadratic. So normal X squared is just that parabola, and it's going to be some variation of X squared. So it would be quadratic. So A would be yes. B, what is the maximum possible area of the pin? Well, we have our function here. Our function is the area is equal to 100X minus X squared. So our graph, if we plug that into our calculator, is going to look something like that, right? So what's the maximum area? What's the key word of that question? Maximum. How are we going to find the maximum of this graph? Huh?
Where the vertex is?
The vertex. So we can either do it in our calculator or use that vertex formula. If we were to use vertex formula, what is our A and B here? What's A?
-1.
-1, right? So it's the thing that's attached to the X squared. And so our B would end up being the 100. And so we can plug that in. -100, because it's negative B over 2A, times 2 times -1. So -100 over -2 should be 50. So our answer to B would end up being 50. These word problems, especially when it comes with drawings and stuff, always look a bit scary. But if you start looking for the key words of each question, it'll help, right? Because we didn't really care about anything this question had to say, except for maximum. We know how to find the maximum of a function. That's not bad. We plugged it into our vertex formula, right? It was nothing we didn't know how to do or some big long question. It was just how to do the maximum. Does that help? Don't get intimidated by the word problems. I know it's kind of hard. It's easier just to say that, but. Any questions on 73, or we ready to move on to the next section?
Sure. All right, so in section 3.2, we switched to solving quadratic equations. And have you guys seen the AC method handout? I'm not gonna.
Do you guys have any tissues? I'll just go to the bathroom.
Okay. Dr. Jenkins, do you have some? She's got some. Okay, so if you guys haven't learned the AC method, that's really helpful. I would encourage you guys to go to the Math Tutoring Center and pick up one of these handouts, or if you'd like, I can also include this in the email I send with you tonight. All right, we'll do that. Okay, so do we have any questions over questions 1 through 10? How about the next section, finding x-intercepts algebraically?
Student number 12.
So if we're given f of x equals 5x squared plus 7x plus 2. And I'm assuming that we're going to be using the AC method for this one as well. All right, so to use the AC method, we're going to look at A and C first. And so we know 5 times 2 is 10. So now we have to look at two numbers that multiply and give us 10 and add to give us 7, which would be 5 and 2. So now we can break this apart and we will get 5x squared plus 5x plus 2x plus 2, which is just breaking the 7x apart into these two pieces. And now we can group these together and we can pull out the common pieces from each. So in this first piece, we can pull out a 5x and we are left with an x plus 1. And in the second piece, we can pull out a 2 and what we're left with is x plus 1. So now we have two x plus 1s, which we can then pull out again. So then we're going to be left with an x plus 1 times, and then what we're left with is a 5x plus 2. So now that we have those two pieces, in order to solve for the actual solution, all we have to do is set this equal to 0, which I'm sure that you guys are very familiar with. Do you need me to work through the rest of the problem, or do you have any questions about how to finish that?
All right, great. And then solving quadratic equations and finding x-intercepts graphically. You guys are all pros at using your calculators, and if you're having any trouble, now's the time to get help with that. We have a request to do question 13.
13, okay.
That's a great question.
So we'll do question 13 here.
There you go.
So we're given f of x equals 4x squared minus 9. So I'd say the easiest step to pull out the 4 first and
Do you still use the AC method for this? Okay, and so this is the difference of two perfect squares. We know 2 times 2 gives us 4 and 3 times 3 gives us 9. Let's go ahead. So missing that middle term is enough to throw you off when you're used to doing the AC method.
so since we're given a 4x squared, we know that, like she said, 2 times 2 is 4. So this squared can actually be broken up like this. So now
Oh, you can, okay.
So are there any questions about how I got to the end there? Because since we're given something squared minus something squared, now using the difference of squares, we can just break that up into this plus and this minus. Do you guys have any questions?
All right, great. All right, so solving quadratic equations and finding x-intercepts graphically. So where do we know our x-intercepts are at? What is y equal to? can answer that.
Okay, so the x-intercepts are going to be where the graph falls along the x-axis. So just for an example, if we're given this graph, those x-intercepts are going to be right here. Any questions about that?
All right. So question 29 through 34 give us the square root method. So in that little snippet from your textbook, we see that x squared equals c, where capital C is a constant. We can solve by moving that constant over to the other side of the equal sign and then taking the square root of both sides. Any questions on that one?
You do number 33.
Number
Sure thing.
33?
Yeah, mask back up. Thank you.
So for this one, the constant is already moved over to the other side, so we don't have to manipulate the equation any further before we take the square root. So now, to get rid of that squared, we just have to take the square root of both sides, which we are then left with x minus 5 equals, and the square root of 9 is 3. But when you take the square root of 9, you can either be given a -3, because -3 times -3 is 9, or a +3. So just remember that this is a plus or minus 3. And then you can break that up into x minus 5 equals -3, and x minus 5 equals 3. And then solve for x. Any questions about that?
All right, how about the next section, completing the square? Had a lot of questions about that one last night.
Can you just do one of the examples of it?
Sure. Is there anyone in particular?
37.
37? Okay.
Good choice.
All right, so the original equation that we're given is x squared minus 3x plus 2 equals 0. So first, in order to start completing the square, you want to move this constant over to the other side. So then we will be left with x squared minus 3x, but we're going to leave a space. And then we'll have the -2 on the other side from where we move that 2 over. And in order to complete the square on this side, we have to find the constant that will let us find a perfect square for that side. So in order to do that, we are going to take this number. Times 2 squared, correct?
Divided by 2. and
Divided by 2
squared.
squared.
Mhm.
Okay, so you will take this b, which is -3, divide by 2, and then you square it, which will be 9/4. So then we're going to add a 9/4 over here, which means we also have to add it to the other side. So then we're going to move over here, and we'll have x squared minus 3x plus 9/4 equals, and then -2 plus 9/4. One.
No.
1/4. Thank you. Okay, so then we can break this up into a perfect square of x plus minus, thank you. X minus 3/2 squared equals 1/4. And then, as we saw up here earlier, we can just take the square root of both sides. Give you x minus 3/2 equals the square root of 1/4. And we can simplify that to 1/2. And then solve for x.
But before we do that, we have to make sure that we put that plus or minus side sign on the 1/2. Because anytime you have a squared term, I could say 2 times 2 is 4, or I could say -2 times -2 is 4. All right, questions on that? Yes,
So why does she divide by 2?
we're trying to find something that whenever you add it up, you get that middle term. And so the easiest thing is to go ahead and just divide that by 2, because we see when we FOIL out x minus 3/2, we'll have 3/2 plus 3/2 gives us 6/2, which reduces to 3.
Okay. And then also you said, just like to get this straight in my mind,
Absolutely.
anytime that you have a square root, you'll have the plus or minus.
Yes.
Okay.
Okay, it changes whenever you have a cubic root,
Uh-huh.
because then we know that if it winds up being -1/2, then the solution has to be negative.
Okay.
Yes, but anytime you have a square, exactly, plus or minus. Good questions. Other questions? Yes,
So you finished doing the -3/2 plus 1/2 and then -3/2 minus.
Yeah, so you'll just break this up into x minus 3/2 equals -1/2. And then x minus 3/2 equals 1/2. And then solve for x.
all right.
Another tip for these is always make sure you plug the answers you get back into the original equation. Because sometimes they can actually not work, they can be a solution that won't work. So, a lot of these, for the ones that took 111 to the diagnostic quiz, there were a couple of these on there. Where you needed to make sure you plug it back in at the end and check your answer. So only one of them would work.
All right, so to make sure we're getting through everything, does anybody have any questions over using the quadratic formula? Pretty comfortable with that? Okay. What about solving quadratic equations having complex solutions? So meaning that I is going to show up. Any questions over those types of problems?
Can you do 52, please?
Sure.
52. We have a 2x plus 1 squared plus 7 equals 0. So to start this, we are going to move this 7 to the other side, which is going to leave us with a 2x plus 1 squared equals -7. But when we take the square root of both sides, over here, this will cancel out, 2x plus 1. But over here, we're gonna have a -7 under a square root. And when you have a negative number under a square root, you know that you're gonna have an imaginary I, because we can't have a negative under a square root. So do they use I's?
Mhm.
Okay, so since this can be broken up into 7 times the square root of -1 and the square root of -1 equals I, we're gonna have 2x plus 1 equals I times the square root of 7. This will be plus or minus. So then we can break this apart again, like we usually do, and we will have 2x plus 1 equals -I times the square root of 7, and we will have a 2x plus 1 equals I times the square root of 7.
How would you finish that one out, or is that just the problem? Or is that just the rest of it?
So
You would wind up moving the 1 to the other side and then dividing by 2. It's going to look ugly because there's nothing we can do with that I except just keep it stuck there to the square root of 7.
So this is what one of the answers will be. Sorry, thank you. And then on the other side, you will do the exact same thing.
So I also want to mention that if you pay real close attention and say we put that -1 in front of the -I plus or -I times square root of 7, doesn't that look an awful lot like our quadratic formula? We'd have -1 plus or minus I times the square root of 7 over 2. So that's how we derive our quadratic formula as well. That's why we know it works. Because even when we do this, we're still getting the same answer.
All right, so let's go ahead and take a look at the next page. All right, So when we're working with the quadratic formula, we see that b squared minus 4ac, so that those two terms under the square root sign, that's called the discriminant. And we can use the discriminant to determine if we have the quantity inside the radical, if there are going to be two real solutions, one real solution, or no real solution. All right, so does anybody need to see any of these questions, 55 through 62 work, determining how many solutions there are, and whether the discriminant is positive, negative, or zero?
Yes. I guess we could do any of them.
Thank you, Felicia. We'll do that. All right, dealer's choice.
All right, well, we can we'll look at one of the ones down here so that we can actually go through it with an equation. So we'll do 59. So we're given f of x equals 3x squared minus 5x minus 2. And so we're gonna look at up here, the b squared minus 4ac. And when we plug that in with our a, b, and c, we will have negative 5 squared minus 4 times 3 times negative 2. And that will give us 25 plus 4 times 3, 12, 24. So we will have 49. Okay, so since we're given a positive 49, we can see that b squared minus 4ac is greater than 0. So we know that there are two different real solutions.
All right, does that answer your question, Felicia?
Yes.
Okay, fantastic. Do we have other questions over this type of problem? Okay, fantastic. Okay, and the word problems here, these are more applications involving quadratic equations. Running a little short on time. We have until 7:30, but we're not quite halfway through the packet. So does anybody want to see any of these work, or shall we move on? Okay. Let's go ahead and look at the next page. All right, so 3.3 moves on to power and root functions. So power functions are those functions where we've got y equals a, x to the b, where a and b are real numbers. Does anybody have any questions over 1 through 7? Just getting our feet wet on those.
I had a question for
Sure.
A and C. What are like two sections?
Which section was that?
Number 2 and C
2C, okay.
Yep.
C
and
Okay.
D.
and
Okay.
B. Okay. So we'll look at,
There you go.
we will look at B first. So we're given y equals 1. Let me write that. Y equals 1 over x. So we can rewrite this as y equals x to the negative 1. And since that follows, the y equals a times x to a b, it is a power function. Does that make sense?
How
Oh,
did you
yeah.
get the x to a -1?
So since this x is in the denominator and x itself is the same as x to the first power. So since it's in the denominator and the power is to the 1 in the denominator, when we flip that into the numerator, we would just change that into a negative.
This is our reciprocal function. The
Oh.
textbook talks about it quite a bit.
So now we can look at C, y equals 3. Okay, so we can also rewrite this one where y equals 3 times x to the 5/4, because we have a 5 in here and a 4 in here. And since this is a root, that will be in the denominator of this power. And since the 5 is inside, that will be the numerator. Does that make sense?
Yes.
All right, fantastic. Okay, so moving right along, let's look at the next page. Okay, graphing power functions, that's just a matter of making sure you can get it into your calculator. So work with a tutor or your course embedded consultant if you're having difficulties with that. How about questions 19 through 22, solving equations involving integer exponents? Questions there. How about solving equations involving rational exponents? And if I've skipped over one, let me know.
I had questions on number 20.
Sure.
Okay. So,
And 22, to be honest.
Okay,
in 22.
bring the honesty. That's what we need.
So we're given 1/8 x to the -5 equals 384. So to isolate this x, first we want to multiply by an 8 on both sides. So we're given 3072, thank you. And then in order to okay, for me to understand this, this is what I have to do. And what we can do now is flip this. So what we're really doing now is raising both of these to a -1. And then we can take the root of that, and then we will get x equals
It's ugly.
3.6.
Here, let me do this instead.
We'll round it up.
Oh, it's just ugly. Seriously. Yeah.
We'll round it at 3.66. So this will be your answer for number 20. And on 22, you're given x to the 2/3 minus 3/4 equals -1/2. And in order to isolate this x, we will move this 3/4 to the other side. So -1/2 plus 3/4, 1/4. And then we need to get rid of this 2/3 exponent. So square root of both sides, and this will get rid of this squared in the top. So we'll have x to the 1/3 equals 1/2. But it will be a plus or minus 1/2 because it's the square root. So then we will have x to the 1/3 equals -1/2 and x to the 1/3 equals 1/2. And in order to get rid of this 1/3 in the exponent, we raise both of these to the thirds. That cancels out. And you will have x equals -1/8.
Good.
And then you will do the same thing to this bottom one. And that's how you solve it. Are there any questions about that?
Nope.
Awesome.
All right.
Okay, how about 23 through 30?
You do number 26.
Sure thing.
26.
That's a good problem.
So we're at 4. It's the square root 2x minus 3 equals 36. So to isolate this square root, we're going to divide by 4 on both sides. And then we're going to be given 2x minus 3 equals 4 times, or
9.
thank you, equals 9. And then in order to get rid of the square root, we're going to square both sides. So then we'll be given 2x minus 3 equals 81. And then solve for x. Any questions?
All right, so while you're writing that down, the next section talks about direct variation as the nth power. So quantity y is going to vary directly as y equals k x raised to the n power. So just applications of what we've been doing so far. And then we move into our word problem section. So if you want to skim through those word problems and see if there's any 37 or 43 or any of those word problems you'd like to see worked.
We do 32.
Sure.
32. Okay. I'll keep that up.
Yep, good.
So suppose that y varies directly as the square root of x. So we want to remember the square root of x, and y equals 16 when x equals 4. So first we can set up the equation y equals k times the square root of x, just by looking back in this beginning. And we're also given that y equals 16 when x equals 4. So if we plug those back into the equation, we can solve for k. So we will have 16 equals k times the square root of 4. The square root of 4 is 2k. Divide by 2 to isolate k, and we have k equals 8. Now we can plug this k back into the original equation. And this is the equation that we will be working with, but we want to find x when y equals 24. So we plug in 24 for y. We have 24 equals 8 times the square root of x. Divide by 8. 24, 3 equals the square root of x. And in order to get rid of the square root, square both sides. This cancels out, and you will have x equals 9. Huh?
So this is a common problem. So it is likely we'll see one of these on your final. And this same problem would show up, but instead of directly, it may say inversely, and I don't know if it covers it.
It doesn't.
But instead of multiplying by the x squared, if it says inversely, we divide by the square root of x. So we're gonna have y equals k either multiplied or divided by something. And directly means to multiply, inversely means to divide.
So it would be x over k.
It'd be k over the square root of x. So the one on the left there is directly, and the one on the right would be if that's set inversely. And so either one of those can pop up in your final. I've seen that happen before.
Any questions?
All right, so let's go ahead and keep scrolling through. We've got 43, 45. Graphing. I had a lot of questions over the next page, section 3.4, talking about piecewise defined functions and absolute value functions. All right, did anybody have trouble evaluating piecewise defined functions? So questions 1 through 4. Or graphing piecewise defined functions.
Yes.
Which one?
It's both of them.
Okay. Do you have 1 through 4? Which one do you want to see?
So look at 4.
So in 4, we're given y equals 3x plus 1 minus x squared. If okay, so just looking at this piecewise function, we know that we will use the top equation 3x plus 1 if our x is less than 3. We will use the bottom equation if our x is greater than or equal to 3. So at top here, we want to find a, which is f of -1 and f of 3. So for f of -1, we know that since -1 is less than 3, we're gonna want to use this top equation here. So when we plug in -1, we'll have 3 times -1 plus 1. So -3 plus 1 is -2. And that will be our answer for f of -1. Are there any questions about how we know that we're gonna use the top equation for this x?
Nope.
And then for B, we want to find f of 3. And looking at these domains again, we know that we will use the bottom equation if x is greater than or equal to 3. And since this is equal to 3, we know that we will use this bottom equation. So when we plug in 3, we will have 3 squared equals 9. Any questions about that?
Nope.
How do you graph the piecewise defined function?
Okay. Is there one specifically that you want to look at?
Number 7.
Number 7.
In the interest of time, let's do 6.
I
Maybe?
agree.
Yeah.
Okay, so
I mean, I'd love to sit here and do math till like cows come home, but.
2 if x is greater than or equal to 2, and 6 if x is less than 2. Okay, so we have a graph here. X and y. We know that y will equal 2 if our domain is greater than or equal to 2. So 2 by 2 is 2, 4, 6, 8. 2, 4, 6. So y is equal to 2. We can look at when x equals 2. And so when x equals 2, looking at this top domain, we know that y is going to equal 2. And since there is a greater than or equal to sign, we know that this right here will be a closed dot. And x is greater than 2. So that will be the line for the top. And then we know that y equals 6 if x is less than 2. So up here, when x is 2, and go all the way up to 6. But since the domain down at the bottom does not have an equal sign, we know that this circle is going to be open. And since its x is less than 2, this is going to go in the negative direction.
So if you were looking at 7, it'd be the same idea, just more line segments. All right, so looking at absolute value equations and word problems, we're down to our last 27 minutes and we still have 30 pages to go. So maybe grab some of the worst or the toughest looking problems. All right, so let's go ahead and scroll. That's another piecewise function graph. Let's go ahead and scroll to the next page. All right, so we had questions over this one last night, quadratic and power model learning outcomes. Finding the equation of a quadratic function given 3 points. Do we have any questions over how to do that?
Can you do number 1 as an example?
Yes.
Absolutely. Okay. Number 1, we're given 0, 1, 3, 10, -2, 15. So we know that the formula for a quadratic function is ax squared plus bx plus c. And using all 3 of these points, we can plug these into our formula until we can solve for a, b, and c. So when we plug in this first point into the equation, we're given, so y equals 1. Then we have an a times 0 squared plus b times 0 plus c. So 0 squared times a is 0, B times 0 is 0, and then we're given C equals 1. So we want to keep that for later. And then we can plug in our next point, 3 comma 10. So y equals 10. So we have 10 equals A times 3 squared plus B times 3 plus, and then we already know what C is, so we can go ahead and plug that into our equation. So we have a plus 1. And then over here, we can do the same thing with our third point, which is negative 2 comma 15. So we know that y equals 15. So we have 15 equals A times negative 2 squared plus B times negative 2. And then again, we know what C is. So we can go ahead and plug in C. So now we have two equations where the only variables left are A and B, and we need these in order to find our original equation. So now what we can do is simplify. So 3 squared, so we have 9A plus 3B. And over here, we have 4A minus 2B. And then from there, we can use elimination to solve this system of equations to
Wouldn't you
find A and
subtract
B.
the 1 though, from both sides?
Yes, thank you.
Yes. Good catch.
Yeah. So from there on, are you guys comfortable with solving that system of equations, or do you need me to work through it a little more?
All right, fantastic. So let's go ahead and look at our next page. Let's see, so more word problems. So this is going to be the same process where you're given data points and you have to take 3 data points and come up with an equation for that quadratic function. Let's go ahead and scroll. Okay. Now this set, find linear, quadratic, or power functions that model data in this table. This will be where you drop these points into your calculator, see what the graph looks like. And then a little bit later in this packet, I have an informational table that shows what all the different graphs look like, whether it's linear, quadratic, cubic, or quartic. Let's go ahead and scroll down. All right, so this is the chapter 4 algebra toolbox. We're not going to go over that, but if you have questions on it, make sure you get the questions answered before you tackle the new stuff. So let's go ahead and skip to section 4.4. That was the one section covered out of chapter 4. The first learning outcome was solving radical equations. And then the next one was solving equations with rational powers. Do we have any questions over problems 1 through 14? Okay, so let's go ahead and keep scrolling to the next page. Solving an equation in quadratic form. Again, this is just going to be factoring, making sure that our roots are real solutions to the equation. Solving a quadratic inequality algebraically. Any questions over those? Okay. Power inequalities, they're going to be like everything we've been doing raised to a power, but this time instead of an equal sign, an inequality sign is in place. What about absolute value inequalities? Any questions over those?
Could we do number 40?
Perfect, yes.
Number 40. So I'm going to go ahead and do it right here. We have the absolute value of 3x plus 1 is less than or equal to 5. So anytime that we have an absolute value, we always have to consider both the positive and negative connotation of it. So we're going to create 2 equations. We're going to get the absolute value by itself, which in this case it already is, and create 2 equations. So we're going to keep the same exact one we have for the positive version. So do the 3x plus 1 is less than or equal to 5. Now, we can go ahead and solve this. Let's go ahead and get if we subtract our 1, we get our 4 over here, which is less than or equal to 3x. And so we would get x is less than or equal to 4/3. That's one of our solutions. However, we also have to account for our negative version. So we're still gonna keep the same thing of the absolute value, our 3x plus 1. But when it comes to inequalities, we need to flip the sign. So we're gonna flip the sign. So we'll have greater than or equal to, and then the negative of the entire other side. So we'll have negative of the entire other side, which in this case is only 5. So we'll have 3x plus 1 is greater than or equal to -5. And so our two equations that we solve for will be this one, and we already solved for this one up here, which is that. Any questions on that? When we have an absolute value, we need of an inequality. We're gonna have our two equations. One side will be negative, one side will flip the sign and be negative, and the other will be the same.
All right. So let's go ahead and keep scrolling down and see what else we've got. All right, so question 47. More word problems, our favorites. All right, and this gets us to chapter 6. Again, we're going to skip that algebra toolbox. And I had the most questions over section 6.3. So let's take a quick look at section 6.1. All right, so 6.1 contains a lot of really useful information where I showed basically a summary of everything we've learned up to this point when it comes to graphs, so that we can compare and contrast a quadratic, linear, cubic, and quartic function. So take some time and look at this little bit of information. I've got the cubic function listed there. Let's go ahead and scroll up. I've got information about a quartic function. A quartic function, when it's just f of x equals ax to the fourth, looks a lot like a quadratic equation that gives us a parabola. But notice that it flattens out the base of that parabola. And then when you include the descending powers, it gives a little bump at the bottom. Okay, so let's go ahead and keep scrolling. And this is the table I was telling you about, polynomial graphs, where we can look at, well, that leading coefficient, what does that do to our slope? We can have a positive slope, a negative slope. Linear function is just going to be y equals 1 to the x. Write down what this is.
So linear is just gonna be y equals x. Quadratic is gonna be y, or if that's an x, y equals x squared. Cubic, like it sounds, is y equals x cubed. And quartic is y is equal to x to the fourth.
So I would just take some time and go through and look at those graphs. All right, make sure you're familiar with the degree.
The degree is what tells us what graphs those are.
So is it first, second, third, fourth? And then that'll also tell you the number of turning points, if there are any. Let's go ahead and scroll down some more. And then, so this is just identifying the graphs of higher degree polynomial functions. So you'll look at it and say, okay, what does that look like according to that table we just saw? Go ahead and scroll some more. Okay, and then identify the degree, coefficient, and intercept of equations of higher degree polynomial functions. So that means we're going to look at what's the largest superscript. So what's the largest number on exponent on x? The coefficient is going to be the number in front of the x with the highest power. And then the intercepts means that we're going to solve for all the roots. Are there any questions on that section or the next one, finding local minima, maxima, absolute minima, and absolute maxima for polynomial functions?
What qualifies something as a higher degree?
A higher degree?
Yeah.
Usually it's going to be something greater than x squared.
Okay.
So x cubed, x to the fourth. We don't use those as often.
Uh-huh.
Definitely x to the fourth and above.
Okay.
All right, let's go ahead and scroll some more and then solve applications involving higher degree polynomial functions. Go ahead and scroll some more. 6.2, modeling cubic and quartic functions. This is going to be dropping these numbers into your graphing calculator and figuring out, okay, does this look like something raised to the third power or something raised to the fourth power? Then let's get to the heart of the matter. Let's go ahead and scroll through to section 6.3. Solution of polynomial equations using the different ways of factoring, okay? So everybody was okay last night with solving factored polynomial equations. Where we ran into trouble was with the factoring. So let's start with questions 5 through 10. They need to see those work.
Can you do 8, please?
Number 8. So we have x to the 4th minus 6x cubed plus 9x squared equals 0. So at the beginning of every function that we want to factor, we should always look for greatest common factors. In this case, it may not be a number, but each term has an x squared here, right? So we can start just by factoring out an x squared. So we know that x squared is in all of these, so we can divide them all by x squared, and that would leave us with x squared minus 6x plus 9 equals 0. And now this one right here ends up looking really familiar to what we were doing earlier, right? So as soon as we take out that greatest common factor, it doesn't look too bad, but let's keep going. So if we use our AC method here, we would see our A, B, and C. Let's go ahead and label those. A is equal to 1, B is equal to -6, C is equal to 9. So we're going to multiply our A and C to get 9, and let's list all these factors. So we have 1 and 9, and 3 and 3, and that's it, right? So which one of these add together to get -6?
-3.
-3, right? So we would know that x squared, so we still got to bring this x squared down, and we can separate this into x squared minus 3x plus 9. And like we were doing earlier, we can kind of group these and we can factor out of them. So this first one we can factor out an x. So we'll factor out an x and be left with x minus 3. Second one, we can factor out a negative 3, which would leave us with minus 3x minus 3. Which then, I'm gonna have to skip over this and do, and so we would be left, because we can factor out that x minus 3, of x minus 3 times the x minus 3 here, which is going to be the x minus 3 squared. That gives us our x squared times x minus 3 squared equals 0. And we can just solve those by setting them both equal to 0. So x squared is equal to 0, which means x equals plus or minus 0, but 0 can't be negative. So x is equal to 0. Same for x minus 3 squared, which is just equal to 0. Square root of 0, don't need the plus or minus. X minus 3 equals 0. And so adding 3 on both sides, we get x equals 0 and x equals 3. And so that, for number 8, would be our 2 solutions.
Actually, 4 solutions. You got
Or
4 roots.
4.
Mhm.
Which would be we would know that neither negative variation would work.
But you have to list out 0, 0, 3, and 3.
Yeah. So we'd have 0, 0, 3, 3. Since that is to the 4th degree. Any questions on that one?
All right, how about factoring by grouping? Questions 11 through 14. All right, what about the root method? We saw some of this earlier, taking the square root of both sides or taking the root of both sides. Okay, let's go ahead and keep scrolling. We've got about 12 minutes. How about this one? Solve and factor polynomial equations using a graph.
Do you number 29?
Number 29.
Sure thing.
So this is telling us to solve f of x is equal to 0 and find the factorization of f of x. We can look at this graph, so we could go through all of our factoring for that and get all those answers. But it wants us to look at the graph and do it. So we want to find f of x is equal to 0. That's just when y is equal to 0. So at every point on y equals 0 is going to be an answer. So we have an answer right here, and right here. We should always expect the same amount of answers as it is to our degree. So we have our 3 here, and we're expecting our 3 answers. So let's see, this first one on the left looks to be -1. So fx is equal to 0 at -1. This one looks like +1. And the one on the far right looks like 5. And so for f of x is equal to 0, that's going to be our solutions. B says find the factorization of x. Is that asking the same thing? Or is that asking me to factor it?
Factor it.
Okay, so now it also wants us to factor out this equation. So our equation is -0.5 x cubed plus 2.5 x squared plus 0.05 or 0.5 x minus 2.5. Well, we can rearrange these in any order due to them being addition, right? They're all some sort of addition. So we also want to factor out things. These, if we factor these two together, if we rewrote this as -0.5 x cubed plus 0.5 x, and then we also moved that this one over with that, we get 2.5 x squared minus 2.5. Notice that's the same exact equation as we have up here. We just moved some things around. And now we can use our factor by grouping, right? So we have this first group here, which we can factor out a -0.05x, so -0.5 x times, well, if we factor that out, we'll be left with x squared plus 1 or minus 1. And then if we factor out a positive 2.5 x or a positive 2.5 from the other one, we get 2.5 times x squared minus 1. Now we have our nice grouping. We can factor out this x squared minus 1. So we have x squared minus 1 times the -0.5x, 0.5x plus 2.5. And we know that's going to be equal to 0 because we want to factorize it, right? We can set each of those equal to 0. So x squared minus 1 equals 0. That's going to leave us with, if we add 1 on both sides, the x squared equals 1. Square root both sides, x is equal to plus or minus 1, right? Because we took the square of both sides, so we have to keep the plus or minus. Let's do the next one. -0.5 x plus 2.5 is equal to 0. Let's subtract our 2.5 on both sides to get -0.5 x equals 2 or -2.5. And if we divide by this 0.5 or -0.5, it should give us x is equal to 5. And if you notice, we have our plus or minus 1, and we have our 5. That's the same as our roots over here. So when we factor things, we're really just looking at the roots of these graphs where f of x is equal to 0. So that's all we're solving for, is where is x equal to 0? Does that make sense? Any questions on that?
All right. Let's go ahead and see what we have left on the last couple of pages with our 6 minutes remaining. So we can solve applications involving polynomial equations and factoring. And we can answer interactive figure questions involving the volume of a box. Anybody want to see either of those done? Go ahead and look at the next page then. Answer interactive figure questions involving zeros of polynomial functions. So we want to see that word problem work. Okay, we have reached the end of our packet. If there are any questions that you'd like to see work that we had to skim over in the interest of time, let us know. Otherwise, if you guys have questions, the odd numbers are in the back of your textbook, the answers are. So look those answers up, make sure you understand, use those learning outcomes. What is it asking me to do? Do I know all the words in here? Mathematicians speak a whole different language, so make sure you're familiar with the terms so you're not lost from the get-go. If you stumble across something, you don't know how to solve it, my contact information is in there. It's Math Tutoring Center, buzz your instructors, hang out with your CPCs, get the help you need, and do amazing on your final exam, okay? Thank you all for coming this evening.
Does everybody know where the Math Tutoring Center is located and what its hours are? Yes, no? No. So the Math Tutoring Center is open Monday through Thursday, 9 a.m. to 8 p.m. There's always somebody staffed in there. You can just walk in, come in. We'll ask you to scan a QR code. You can take a seat, work on homework or whatever, and we'll be there to help. On Fridays, it's only open from 9 a.m. to 3 p.m. And the location is in Wallace 342. So that building across the way over there is Wallace. It's just an ugly brick building. And so on the third floor, we are room 342. There's a sign out front that says free math tutoring.
All right, and then I will follow up this evening by sending everyone an email with the AC method, with annotated packet with all the notes that we took, and with a link to the video. All right, thank you all so much for coming. We appreciate it.